Alright, quick and easy video, let's go. I'm going to prove all of these identities you see on screen using just one of them, and obviously the proof for that one. And just quickly to get this out of the way, I do not consider all of these identities as identities which require being proven, since they're either definitions or just self-explicable by taking a look at the unit circle. This video is going to consist of one proof, and then just algebra for the rest of it. So if that makes you sick to your stomach, then, so let's start off with the first one, the difference angle identity for the cosine. And you might think it's really weird to start with this, but I just really like this proof, and also it doesn't really matter which one we start with. Before we explain it though, we need to go over one thing. If we have 2 points on the Cartesian coordinate system, how do we find the distance between them? Well, it's very simple actually. If we have a point and assign it the coordinates x1, y1, and then another point with coordinates x2, y2, now we can imagine that this distance is the hypotenuse of a triangle, and then we just need to find out the lengths of these two legs of the triangle. We can do this by taking x2 and subtracting x1 from it. Then we will get the length of the leg along the x-axis. Then we subtract y1 from y2, and we get the length of the leg along the y-axis. Then we use the Pythagorean theorem, a squared plus b squared is equal to c squared, so our formula turns into this. The distance is equal to the square root of the leg along the x-axis squared plus the leg along the y-axis squared. And now just real quick, it doesn't actually matter whether or not you subtract x1 from x2 or x2 from x1, since it's going to give you the same result in the end. One is instantly going to give you the length of the leg, and the other one is going to give you the length but in negative. And this still works because then when the length gets squared, whether or not it's negative or positive, a squared number is always positive. Yeah. Alright, I'm assuming you know a bit of trig explained in the unit circle, but even if you don't, I'll give you the quick rundown. Sine is a function which takes in an angle of a triangle as an input and gives out a ratio. That ratio is the opposite side of the angle divided by the hypotenuse. And notice that the hypotenuse of a triangle is always going to be larger than or equal to any of the sides of a triangle. So this sine function is always going to be between -1 and 1. Then the cosine function. The cosine function is the same as sine, takes in an angle and gives out a ratio, with that ratio being the adjacent side divided by the hypotenuse, not the opposite side this time. Once again, this fluctuates from -1 to 1, however the key difference is that when sine is 0, then cosine is 1, and vice versa of course. This will become important later. There are also 4 other trigonometric functions: the tangent, cosecant, secant, and cotangent. The tangent is defined as sine divided by cosine, and these functions are just 1 divided by their corresponding function. So this is 1 over sine, this 1 over cosine, and this 1 over tangent. However, it can also be expressed as cosine over sine. Now let us take this equation. X squared plus y squared is equal to 1. This gives us a circle because this is the Pythagorean theorem, meaning that for every x and y, the hypotenuse has to have the length of 1, or the radius of the circle is equal to 1. Now x and y can only take on values from -1 to 1, otherwise the equation wouldn't hold, and you might notice that sine and cosine also only go from -1 to 1. So we can turn this equation into sine squared theta plus cosine squared theta is equal to 1. And this is true, this is a correct statement. Quick side note, any trigonometric function with the square symbol between the function and the angle just means that the entire thing is squared. This is done not to cause confusion, so people don't think that the angle itself is squared. Anyway, we can visualize this as the cosine being the leg along the x-axis and the sine being the leg along the y-axis. So we can represent each point in the circle with coordinates, just like how we would give a point coordinates x and y. This point on the circle will have coordinates cosine x, sine x, with the angle being x. Alright, with that out of the way, let's take the unit circle and an angle alpha with coordinates on the unit circle being cosine alpha, sine alpha, and then an angle beta with the corresponding coordinates being cosine beta, sine beta. Now we can find out the distance between these 2 points as I showed before. For simplifying sake, let's just square the distance so we won't have to draw a square root every single time we try to do something with the distance. That being said, the distance squared is equal to cosine alpha minus cosine beta all squared plus sine alpha minus sine beta all squared. We can calculate this out and we get cosine squared alpha minus 2 cosine alpha cosine beta plus cosine squared beta plus sine squared alpha minus 2 sine alpha sine beta plus sine squared beta. And as we defined earlier, sine squared alpha plus cosine squared alpha is equal to 1, So these two will cancel out and give us 1 because they're both the angle alpha, and these two will cancel out and give us 1 because they're both the angle beta. And we're left with 2 minus 2 times cosine alpha cosine beta plus sine alpha sine beta. So that is the distance squared between these 2 points. Let's put that in our back pocket and move on with the proof. Now we're simply going to rotate this triangle so that this point on the right is at coordinates 1, 0. And this movement subtracted an angle of exactly beta, so these points are going to be at an angle alpha minus beta, meaning they're going to have the coordinates cosine alpha minus beta, sine alpha minus beta. Now we can find the distance between these 2 points using the exact same process as we did earlier. If you want, I leave it up to the viewer to get the result, but the end result is going to be this, 2 minus 2 cosine alpha minus beta. And now since we only moved this triangle, we didn't actually change any lengths or shapes, that means that this distance is going to be equal to this distance. So we can set them equal to each other. Now let's scavenge around in our back pocket and find our equation from earlier. This is going to give us 2 minus 2 times cosine alpha cosine beta plus sine alpha sine beta is equal to 2 minus 2 times cosine alpha minus beta. Now we just do some simple algebraic manipulation. We subtract 2 from both sides, multiply by -1, divide by 2, rearrange, and we get the final formulation. Cosine alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. There you have it. That is the difference angle formula for cosine. This is the only proof we're going to go over in the video. The rest is just going to be deriving formulas from this one. Alright, so first let's get the sum angle formula for cosine. So how would we do that? Well, we can just replace the b with negative b in our original equation. So it would turn it into a plus b, but we could still plug it into our formula. When the angle in the cosine is negative, it doesn't change anything. When it's negative in the sine function, it's the same as changing the sign of the output. Why? Well, if we were to show the cosine in the unit circle along the x-axis, it would be like this. We start with the angle being 0 and the cosine function being 1. As the angle increases, the output gets less and less until it turns negative on the other half of the circle. So the progression of the sign of cosine is positive, negative, negative, positive. So this half of the circle is positive and this half is negative. When we have cosine and our input is negative, instead of moving counterclockwise, we move clockwise. And notice that it's the exact same signs as the normal positive input. Positive, negative, negative, positive. So cosine negative x is equal to cosine of x. This is not the case for sine. Sine starts at 0 and grows from there, with the progression being positive, positive, negative, negative. When the input is negative, it's the opposite, so sine negative x is equal to negative sine of x. That turns our equation into this. And now we have the equation for the sum and difference angle formula for cosine. I'm going to note it down like this because it's more compact. Also, this symbol is plus minus, meaning either plus or minus, and this symbol is minus plus. There's a difference. Basically, minus plus always comes with a plus minus, and it means that the symbol is the opposite of the plus minus. So when this is plus, then the minus plus symbol turns to a minus, and vice versa, of course. Next, how do we get sine from this? Well, cosine and sine have a certain relation to each other. That is, cosine and sine are the exact same thing, but cosine is just one ahead, or sine is one behind, whichever way you want to look at it. So for example, the values of sine for 0, 30, 45, 60, and 90 degrees are 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. And this pattern repeats over the entire circle. You can imagine the sine function as a bar expanding and contracting, and its height being correspondent to its output. This is the exact same for cosine, but the other way around. It starts at 1, so it starts fully expanded, and goes to 0. So what we can do is have it start at negative 90 degrees. That way it starts at 0 and its progression, so its output values are going to be exact same as for sine. So once again, we can modify the original formula by making, for example, the first angle a minus pi over 2 radians. So that turns cosine a minus pi over 2 plus b is equal to cosine a minus pi over 2 times cosine b minus sine a minus pi over 2 times sine b. Now, as we established earlier, this cosine a minus pi over 2 turns into sine a. However, what happens with this sine a minus pi over 2? Well, once again, we can look at the unit circle and move pi half clockwise. We see it's fully extended, meaning it's cosine. However, since the original function is sine, this half of the circle is negative, so this turns sine a minus pi half into negative cosine. And two negatives make a positive, so the final equation is sine a plus b is equal to sine a times cosine b plus cosine a times sine b. Now, I didn't prove or show how to derive sine a minus b, so I'll leave that up to you. And lastly, we're going to go over the tangent sum and difference angle formula. As I said briefly earlier, the tangent of theta is defined as the sine of theta divided by the cosine of theta, and that also applies here. The tangent of a plus minus b is equal to the sine of a plus minus b divided by the cosine of a plus minus b. Let's just expand this out. Now what we're going to do is simplify by dividing every single one of these terms by this bottom left term. You might think that this is not like an obvious thing to do, like why and how is this algebraically correct? And just I'll leave it as an exercise for the view. First and easiest of all, this just turns into 1. Then in this upper left term, these cosine b's cancel out, giving us tangent a plus minus this second term where the cosine a's cancel out, giving us tangent b. All of which is divided by 1 minus plus this, which we can rewrite as tangent a times tangent b. And there we have our final formula. Now we have the sum and difference formulas for sine, cosine, and tangent, but not only that, but also for cosecant, secant, and cotangent, since they're just 1 divided by the respective formula. And this is the last time I'll mention this, because it's the same for everything else. Cosecant a plus b is equal to 1 over sine a plus b, cosecant 2 theta is equal to 1 divided by sine over 2 theta, of 2 theta, cosecant, next. Double angle formulas, because they're incredibly simple. In fact, I suggest you to only learn the sum and difference angle formulas because it is a matter of doing it in your heads to get the double angle formulas. In order to get the double angle formulas, you just take the sum angle formula and make both angles the same. It's as simple as that. Now pause the video and go do it. I'll give you 5 seconds. Alright, time over. The answer is this. For sine, you can just factor it out here, giving you 2 sine theta cosine theta. For cosine, you can multiply these, giving you cosine squared theta minus sine squared theta. Right, side note number 2, this is the Pythagorean identity we established earlier. We can move this around to get either cosine squared in terms of sine, or sine squared in terms of cosine. Or just sine and cosine if you take the square root. Now back to this, as we established real quick, we can change the sine squared to 1 minus cosine squared, making our final equation cosine 2 theta is equal to 2 cosine squared theta minus 1. Or we can change the cosine squared to 1 minus sine squared, giving us cosine 2 theta is equal to 1 minus 2 sine squared theta. And then tangent turns this into 2 tan theta divided by 1 minus tan squared theta. And it was important to specify that cosine has 3 answers, because from these we get the half angle formulas can be derived from either one of these double angle formulas for cosine, depending on if you want the half angle formula for sine or cosine. Let me show you. If we take this and half all the angles, we get cosine theta is equal to 1 minus 2 sine squared theta half. We can then solve for sine theta half and get plus minus square root of 1 minus cosine theta all over 2. Same thing if we take this equation. We can solve for cosine theta half and get cosine theta half is equal to plus minus square root 1 plus cosine theta all over 2. We can now get the half angle formula for tangent using the definition, so tan theta half is equal to sine theta half divided by cosine theta half. Now let's expand this out. This turns it into plus minus square root of 1 minus cosine theta all over 2, all over 1 plus cosine theta all over 2. Then we can square both sides and multiply this fraction by its reciprocal. Then we cancel out the 2's and get 1 minus cosine theta divided by 1 plus cosine theta. We can now multiply with 1 plus cosine divided by 1 plus cosine. This will turn the numerator into 1 minus cosine squared theta and the denominator into 1 plus cosine theta all squared. From the Pythagorean identities, we know that the numerator turns into sine squared. Now remember, we squared the tangent, so now in order to get the half angle formula for tangent, we need to take the square root. And this actually nicely cancels out both exponents here, turning it into tan half theta is equal to sine theta divided by a 1 plus cosine theta. Now there's actually 2 solutions for this equation, and to get that, we're going to just multiply the result we got with 1 minus cosine theta divided by 1 minus cosine theta. We can leave the numerator as is, and the denominator turns into 1 minus cosine squared theta. The denominator then turns into sine squared theta using the Pythagorean identity, And we can cancel out these two signs, giving us tan theta half is equal to 1 minus cosine theta divided by sine theta. Add that to our collection, and now we have the sum and difference formulas, the double angle formulas, and the half angle formulas. Now lastly, we're going to derive the sum to product and product to sum formulas. For example, if you have sine A plus sine B, how would you solve that? Or if you have sine A times cosine B? Well, you just calculate each one and add them together. Simple as that. But fuck that, alright? There's still formulas we can use, and even though these might not be so important to trigonometry itself, they can still be useful sometimes, and they especially get useful in calculus when you have to simplify trigonometric expressions. All sum to product formulas take on either this form, that is sine A minus B plus minus sine A plus B, or the same thing but with cosine. I'm gonna go over the calculation because it's literally just addition and subtraction in its simplest form, but these are the values that come out at the end. I also showed you the calculation because you will notice that when this is the minus, then the result is twice the second half of just the sum difference angle formula, with the special case being sine because the result is negative. When this is plus, then the second half gets cut away and the answer is the first half. This is just something so it's easier to memorize. Also, if you forget, you can always just calculate one of these out and you'll probably remember this rule. Now we have product to sum formula, but at the same time, we have a sum to product formula if we just flip the left hand side and the right hand side around. Now we just need to figure out how to make that alpha minus beta into one angle and alpha plus beta into another. Well, how about we just do that? Let's just set A to alpha plus beta and set B to alpha minus beta. We can solve for alpha if we add A and B together, giving us 2 alpha. So alpha is just equal to A plus B over 2. Then we can get beta by subtracting B from A, giving us 2 beta, so A minus B over 2 is equal to beta. Let's plug these definitions into our original equation. This turns this angle into A and this one into B. Then we just plug these definitions of A and B into the right hand side of the equation, and we get our first sum to product formula. Repeat these steps for all the other formulas and we get this. Now finally, add those formulas to our list and we have all the identities. And remember, they were all derived from one single formula, one single proof. I hope you can do something with that information. Also, I'm out of space on this page of the Google Doc, so bye bye.